So, good morning to all. Let us discuss integration in physics. Now, why do we need integration? The concept of integration was born from a need for a method of finding areas. Recall that the area beneath a velocity time graph gives the displacement of an object. With that in mind, find the displacement for each of the following plots. This is one plot and another plot. Here, easy to find area? Not so easy to find the area in the second graph. Here, area is 5 units, x is equal to 0 to x is equal to 3. So it is not always easy to find the area of a region, especially with the curved side. Thus the need for non-algebraic method. To tackle this problem, we could divide the area of the curve into multiple rectangles whose width are all equal and heights are the value of the function at the right endpoints of each interval. By finding the area of each rectangle, then adding all the areas, we can approximate the area beneath the curve. So, as this curve is divided into multiple rectangles whose width are same and heights are equal are the values of the function at the right endpoints of each interval. So by finding the area of each rectangle, by summing up or adding up, we can approximate the area. So it is from the summing process about the integral was considered. So what is integration? Although as you will learn in your calculus classes, the process of integration is not always simple. The fundamental idea behind the process of integration is a simple idea. You can simply think of an integration as just a fancy name that describes the process of finding the antiderivative of a function. Obviously, there is more mathematically to discuss. Let us start simply. Derivative, what is the derivative of 3x square plus 2x plus 5? As we have discussed in the previous slide of differentiation, so derivative means the dy by dx of this function. So that will be equal to 2 into 3x plus 1 into 2, and that is equal to 6x plus 2. This you have already learnt. Now integral, what do you take the derivative to get 2x? For example, here you are getting 6x. So 6x is derived from 3x square. So simply, what do you take the derivative of to get 2x is x square plus 6. So this is the good thing that you have explored the derivative to get the derivative 2x. So x square plus c will give you the derivative 2x. So derivatives and integral, they are the reverse process. Notation. Integration symbol, an elongated S from the Latin meaning sum. Limits of integration. Integrand, the function to integrate. Variable of integration means what you integrate with respect to. So fx is integrated with respect to x. A and b, they are the limits of the integration. Indefinite integrals. Indefinite integrals will not have limits of integration. The result of integration is integrating is a function. For example, gx is equal to integrating 2x square plus 12x plus 6 dx. So what will be the integration of this result? This you will get 2 by 3x cube plus 6x square plus 6x plus c. But how? Here again we have used a formula. Now let us first consider or understand from where this c constant term has come. Now definite integral will have the limits of integration. The result is a number. This is governed by the fundamental theory of calculus. If f is continuous on AB, then integration of a to b fx dx is equal to fb minus fa, where f is the antiderivative of f. So for an example, if integration definite integral 1 to x square dx, this will be equal to 1 by 3 x cube plus constant. Now here this is a single line, not the sign of integration, means the definite integral means the limits from a to b. So first we will integrate this. Now when you integrate x raised to power 2, the result will be increase the power by 1, that is 3, and divide it by the same number or the power 3. So this is 1 by 3 x cube plus the constant term c and the limits 1 to 4. So now then put the value of the higher above value in place of x. So that is 1 by 3 4 cube plus c minus lower limit, that is minus 1 by 3 x 1 cube plus c. So what you will get here, 64 by 3 plus c minus 1 by 3 minus c. The constant terms, they cancels out each other. The constant terms always cancels while finding a definite integral, so we leave it out. So some simple rules of integration and other shortcuts. The subject of integration is a huge branch of mathematics in of itself and cannot possibly be contained here in this one tutorial. Hopefully, though, you now have some knowledge and appreciation for what antiderivatives are. The following are commonly known formulae for antiderivatives. Derivative integration of dx means when only the integration with respect to what function x, then result will be x. This is a very important formula used in physics. So integration of x raised to power m is 1 upon m plus 1 x raised to power m plus 1. That is integration of, if you are integrating 2, then increase the power by 1. So 2 plus 1 3, and now divided by the power, that is 3. So x cube by 3 is the integration of x square. Now in place of x, the formula is x raised to power m. So integrating means increase the power by 1 and divide by the same power. This is the result for the integration, but the condition that m is not equal to minus 1. Other formulas, they are also used in mathematics, but for the physics only this formula and this one. Integration of dx upon x, that is x raised to power minus 1 dx, is the log x to the base e. These two are commonly used, and in that this one is the most commonly used formula. So in your maths class, you will learn various methods of integration. The following methods that will come in this class: integration by parts, in trigonometric integrals, trigonometric substitutions. Your maths class will also consider if a function is non-integrable function. All functions presented in this class will be integrable. So now in physics, what is this? Now suppose this is position, velocity, acceleration. Then for the differentiation position, you will get the velocity. Differentiating velocity, you will get acceleration. Integrating, if you integrating acceleration, you will get velocity, and integrating velocity, you will get position. So in physics, this is we are using in differentiation as well as in integration, and basically the two main formulas for the differentiation and one for the integration, they are used in the total physics. So thank you.